Hi guys, and welcome back. If you didn't already see my post about this on Google Classroom a few days ago, I did, which you should have, considering it has been a few days, you should have read that by this point, so you should hopefully already know that you guys are going to have a little check assignment on Tuesday leading into Wednesday. I want to call it a check because I don't really like with the whole online learning situation, things are already weird enough that like giving you guys a normal quiz is like kind of not possible. You know what I'm saying? So if you scroll back a couple days in Google Classroom, I made this really long post. What was that? Maybe Thursday or Friday last week about how this check sort of thing is going to operate. Yeah, I don't want to call it a quiz. I did already put a space for it in Genesis. But because of that, like, I do want to talk about, today is sort of like a review day for this check, not really quiz type thing, you know? Because what I am checking is to see how well you understand everything that we've been talking about over the past several weeks, which includes all the different types of methods for solving quadratic equations, factoring, square roots, completing the square, quadratic formula. There's some discriminant stuff, and also since we did a whole bunch of stuff with square roots, I do want to talk about simplifying square roots and a couple of the really tiny little things that we've done with square roots over the past couple weeks. Sorry. So you guys should have all of your notes for all of that, so you can use that for reference. And we're just going to go through a bunch of problems on those types of things. There will be a review sheet as your assignment. You'll get the review sheet tomorrow morning. And yeah, again, scroll back a little bit on Google Classroom to see how the check is going to work. All right. So way back, more towards the beginning of this online learning business, we talked about solving quadratic equations by factoring. All right, so I hope you guys remember factoring. Just in terms of factoring, the problems pretty much look like this, where it was just a quadratic trinomial. And for a problem like this, well, actually in general, when we try to factor, the first thing we would have to do is look for a GCF. So is every single term in this quadratic trinomial divisible by the same number? Do they have any variables in common? And the answer to both of those questions is no. They don't all have an x. And they technically are all divisible by 1, but as I'm sure you guys know by now, if you divide anything by 1, it's not going to change anything. You know, so we don't have to take out a GCF, and we're just worrying about, the next thing we worry about is the fact that the leading coefficient is 1. So that means all we have to worry about is factors of 12 that add up to -7. All right, I think most of you guys probably already know what they are, but just for consistency's sake, I think you remember we listed out all the factors of 12 first, including your signs. So what are the factors of 12? 1 and 12. We can make them both negative because we want positive 12, so the signs have to be the same. So either both positive or both negative. 2 and 6, make them both negative. 3 and 4, and make them both negative. Okay? And I think that's it. So which of these options adds up to -7, -3, and -4? So the way that trinomial factors is x minus 3 and x minus 4. And now's when we have to remember to include that equals 0. All right, the equals 0 is very important because now we're going to use this thing called the zero product property, which lets you split up these two binomials into two separate equations. So x minus 3 equals 0 and x minus 4 equals 0. And now we have two separate equations that we can solve like we've been doing since the beginning of the school year. So one of our answers is x equals 3. And another one is x equals 4. All right? I feel like I've said multiple times by this point, with quadratic equations, you do typically get two solutions. You can get maximum two solutions. There are some times where you're only going to get one solution, and sometimes where you're not going to get any solutions at all. If you were told to check your answers as well, it would be the exact same thing that I just dropped my marker. It would be the exact same thing that you would expect. You know, you would take these one at a time, plug them in for x, and you should get 0 for both of these. All right? Okay. So the whole reason why it's called the zero product property is because you can't do anything with this unless it equals 0. All right, so the very first thing you have to think about, or the very first thing that you want to do, is get everything, all the variables, all the numbers, all over to the same side of the equation so that the other side, usually the right side, is equal to 0. All right? My trick, if you also remember, is the fact that I also recommended you keep the squared term positive. So since we have positive 7r squared, we're going to keep this on the left and move everything else over to the left side. So that means we're going to subtract 11r from both sides. And since we're factoring, we do want to keep this in standard form. So 7r squared minus 11r minus 6 is equal to 0. And now we can go in and just try to factor the trinomial. Now this is a different kind of factoring because the leading coefficient is not equal to 1. If you think about a GCF first, none of these numbers are all divisible by the same thing other than 1, so we don't have to worry about that, but we do have to approach this a little bit differently. All right? We want to consider both factors of 7 and factors of -6. So factors of 7 are easy. It's just 1 and 7. Factors of 6, you have a little bit more room to play with. With 6, I don't know if I said this already, but with this kind of factoring, you don't want to worry about the signs until the very end. So we're just focusing on factors of 6 for now. They're 1 and 6 and 2 and 3. And then we're going to play around with these combinations and these orders until we get something that gets us -11. All right? So we know 1 and 7 is going to stay as is. We have r and 7r. I'm going to pick 2 and 3. All right? Now, in order to see what our signs could possibly be, we do have to sort of check this. All right? We know r times 7r is 7r squared. We know 2 times 3 is 6. So really the only things that we would have to check are the outers and the inners and see if it's possible to make -11. 2 times 7r is 14r, and r times 3 is 3r. Now the nice thing, I honestly didn't know this was going to happen, but the nice thing is that we are able to make -11 right away. So this looks like it's going to be it. -14 plus 3 is -11. So that means this is -2 and this is +3. All right, and -2 times +3 is still the -6 that we have in the original. So that's good. Okay. Now we have the equal 0, and then it's exactly the same as the last problem. We can break up the two binomials and set them both equal to 0 and then solve. So r minus 2 equals 0, and 7r plus 3 equals 0. So that means r is 2. And I don't know if I made this clear from the beginning. I would much rather see fraction answers, especially when we get into radicals in a few minutes. I do not want to see any decimals when you're dealing with radicals. Keep the radicals, keep the fractions as well. All right, so we're going to leave this as -3/7 for our second solution. All right? This is what I'm talking about with radicals, all right? We do not just want to plug the square root of 360 into our calculators and get a decimal approximation. We want to leave a radical somewhere in there. But the idea is we want to find factors of 360 that are perfect squares, which again brings us back to this perfect square reference sheet. My suggestion is to find the biggest perfect square that goes into 360 because then you can simplify the whole thing in one step. So how are you going to do that? Well, where would 360 fall on this perfect square list? It's going to fall between 324 and 361. So the biggest perfect square that's smaller than 360 is 324. So we're going to start in our calculators by doing 360 divided by 324 and see if that gets us a whole number. It doesn't. So what that means is then we're going to go 289 and continue to go up this list until we get something that divides nice and evenly. I have a feeling on what this is going to be, but I'm not sure. So let's just kind of go through the whole thing. So, oops. And as I've said, if you know, like I know that 360 isn't divisible by 100, so if I was doing this myself, I wouldn't check that. If you are aware of these things and you know that like 360 divided by 100 isn't going to give you a whole number, you don't have to sit there and check it, but you can if you want to. Oh, that was 81. Wait, okay, 360 divided by 81 still doesn't get us anything. Yeah, that's kind of what I figured. The biggest perfect square that 360 is divisible by is all the way down at 36. 360 divided by 36 is 10. So that means the square root of 360 breaks down into the square root of 36 and the square root of 10. Okay? We know what the square root of 36 is. That's our perfect square. It's 6. 10 is not a perfect square, but again, we don't want a decimal approximation. We want to leave the radical in there. So we're going to leave this as the square root of 10, and that's our final simplification for the square root of 360. Okay? Now with radicals and fractions, all right, it is against the law in the math world to have a radical in the denominator of a fraction. So the way we get around that is through this process called rationalizing. And all that really means is we're going to multiply both the top and the bottom of our fractions by whatever radical you see in the denominator. So that means we're going to multiply by root 2. Okay? You are also you're only allowed to multiply things that are both underneath a radical. So we're not going to multiply 5 by root 2 because they both do not have a radical, or they both have a radical. You know what I mean. One has a radical, one doesn't. All right. So we're not going to combine them. They're not quote unquote like terms. That's the phrase that I was looking for. The 3 and the 2 though, they both do have the radical symbol over it. So we can do 3 times 2 and then just put the radical symbol above it. So this is 5 root 6 over, and this is the shortcut, all right? We know we're going to use the same process for the square root of 2 times the square root of 2. It's the square root of 4. But 4 is a perfect square. The square root of 4 is 2, and that's the whole reason why we do this. The square root of 2 times the square root of 2 means that the radical symbols are going to cancel out. So root 2 times root 2 is just 2. Okay? We always have to try to simplify the square root, the radicals if we can. Root 6 doesn't simplify. We talked about the factors of 6 in one of the factoring problems earlier. But we do have to try to reduce fractions as well. And again, we're only sticking with either things that are both whole numbers or things that are both underneath a radical. So we would not be able to simplify root 6 over 2 as root 3. That's not possible. They both don't have a radical. We would only be dealing with the 5 and the 2. So 5 over 2, can you simplify that? No. So that's actually it for this problem. Okay? All right. When you solve by taking square roots, again, all of these have different things that you got to think about. All right? We want to isolate this b squared first. So get rid of everything else around it. So that means we'd have to divide both sides by 9. So b squared is 9. And now, if we're solving by taking square roots, now that the b squared is isolated, we can take the square root of both sides. So this is going to cancel out. And you can use your perfect squares reference sheet, or you can do this in your calculator to show that the square root of 9 is 3. But remember what I said earlier, when you're solving quadratic equations, you'll probably get 2 solutions most of the time, all right? So when you're taking the square root, if you think about squares, we know the square root of 9 is 3, so that means 3 times 3 is 9. But negative 3 times negative 3 is also 9. So that means when you take the square root, your square root could be positive or your square root could be negative. There's 2 possibilities, which means there's 2 answers. B could be positive 3 or negative 3. And the way we show that is that little plus minus symbol, just for nice and easy notation. You could, I don't think I've seen anybody do this in these past few weeks. You could absolutely list them separately. And I think you guys hopefully picked up on this as we moved through the sections and as we moved through the different methods of solving quadratic equations, that a lot of the time it's really just easier to leave it as plus minus 3. It's simpler, it's faster, and it says the exact same thing as 3 comma negative 3. Okay? So, again, we want to isolate v squared. So we're going to subtract 10. V squared is 20. And then we're going to take the square root of both sides. Now the thing is, 20 is not a perfect square. All right? I am going to make a note of this on your check. That I don't want to see any decimals as part of your final answer. All right? So if you don't have any perfect squares, or if you don't have a perfect square number that you're taking the square root of, we're going to try to simplify the radical, which means going back to this whole thing. All right? Where 20 is in between 16 and 25, so we're going to start out dividing 20 by 16 and going up the list. I think, hopefully, you guys know that 20 is not divisible by 16, it's not divisible by 9, but it is divisible by 4. So, and 20 divided by 4 is 5. So the square root of 20 breaks down into root 4 and root 5. 4 is our perfect square, it's 2. 5 is not a perfect square, so we're going to leave it alone. Okay, that's 5. And because we are actually solving an equation and evaluating a square root, that's why we need that plus minus. All right, you got to be careful with the directions. If it just said simplify, you don't need to worry about the plus minus, but if it said solve, then you do, and you have square roots going on. All right. Now our squared term is the entire set of parentheses, because this entire set of parentheses is the thing that's being squared, So again, we're going to divide by 10. And this is 81. Square root, that is a perfect square this time. It's 9. But we do need that plus minus, because now this is different, all right? Once we have an expression, it's sort of like what we were doing with factoring earlier, where we were breaking it up into 2 separate equations, but now it's different, all right? The k plus 1 is going to stay exactly the same, and what's going to be different about the 2 separate equations is the fact that one is going to be equal to positive 9, and the other is going to be equal to negative 9. And then we can solve them like normal. So k is 8. And negative 10. Okay. Just the actual completing the square process involves that b over 2 squared idea. All right? So what's our b value here? It's negative 30. So all we're doing to fill this blank in is negative 30 over 2 squared. Negative 30 over 2 is negative 15, and negative 15 squared is 225. So what's going in that blank is positive 225. Again, negative times negative is positive, so that's why there's always going to be a blank here with these types of questions. Okay? All right. A little bit different, because now we actually want to solve by completing the square. So the very first thing that we would have to do is actually complete the square, which means we're going to need some blank spaces. b squared plus 18b plus blank, and whatever you do to one side, you have to do to the other. So if you have a plus blank on the left, you need a plus blank on the right. We're going to do the exact same thing to fill in that plus blank. 18 over 2 squared. 18 over 2 is 9. 9 squared is 81. So both of these blanks, again, same thing on both sides of the equation, filled in with an 81. 63 plus 81 is 144. And then we're going to factor this. All right, I don't know if you guys remember my little trick, but the trick that the book does talk about is, we have this plus here, so we know it's going to be b plus something. But you can use a little trick that it's going to be b over 2. It's going to be the exact same number in both sets of parentheses in your factors. All right, because again, if you think about it, what are factors of 81 that added to 18? 9 and 9. Okay, so your factors or your parentheses would look like b plus 9 and b plus 9. And I'm sure you guys remember b plus 9, b plus 9, if you have this exact same set of parentheses twice with the same sign, same number, same everything, you can condense it, you can simplify it to say b plus 9 squared. And now this is exactly the same as before. It's a solving by square root problem. You take the square root of both sides. B plus 9 is equal to the square root of 144, which is 12. But because we're evaluating a square root, that's why you need the plus minus. So it's plus or minus 12. And then we're going to break it up. B plus 9 equals positive 12, and B plus 9 equals negative 12. And then solve each. So B is negative 21. Yeah. There you go. So that's the format that we want when we're completing the square. If we don't have that format, we have to get it to look like that format first. And what I mean by that format is all the variables on the left and all the numbers on the right. So we're going to have to move this 39 over first. Now this is a minus 16. Okay. And then it's exactly the same thing that we just did. All right. Oh, so this should be K here. Plus blanks on both sides. Negative 16 over 2 squared. Negative 16 over 2 is negative 8. Squared is 64. What are factors of 64 that add up to negative 16? Negative 8 and negative 8. It matches up with the same b over 2 strategy. So this is k minus 8 times k minus 8, or k minus 8 squared, equals negative 39 plus 64 is 25. So we've got another nice perfect square here. When we take the square root of both sides, we get k minus 8 equals positive or negative 5. Break that up. K minus 8 equals 5, and k minus 8 equals negative 5. And then we're going to solve. So k is equal to 13, or k is equal to 3. Okay? Don't forget also about the possibility of simplifying radicals. If you didn't have a perfect square here, you would always have to simplify the radical and then just add 8, and you can leave it, like 8 plus or minus root 5 or something like that. That would absolutely be fine as a format for your final answer. I think there might be a couple questions like that on your review sheets that are going to be your assignments for today. But as always, question forum. There's video call signups that you guys can still use. Okay. Quadratic formula. So with quadratic formula, we want everything all over to one side and having it equal 0. All right? Because the quadratic formula, if you don't remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is what tells us what our A, B, and C values are. It goes in order of your coefficients or your constants. A is 2, B is 10, and C is 8. So negative B, negative 10, plus or minus the square root of 10 squared minus 4 times 2 times 8. All over 2 times 2. So negative 10 plus or minus, now we want to simplify everything. All right, so I'm doing a couple different things at once. I'm sort of dealing with some stuff that's underneath the radical. Following order of operations. Exponents, 10 times 10 is 100. Negative 4 times 2 is negative 8. Times negative 8 is negative 64. So this is 100 minus 64, all over 2 times 2, which is 4. 100 minus 64 is 36. And 36 is a perfect square. So I'm going to do this up here. It's 6. So this is 10 plus or minus 6 over 4. And then again, we're going to break it up. But now that it's an expression, we're just going to simplify this expression. So negative 10 plus 6 over 4 is negative 4 over 4. So that's negative 1. And negative 10 minus 6 over 4 is negative 16 over 4, which is negative 4. So those are our two answers. And same thing, if you have the time or if you want to check it, plug these both in for x, one at a time, and you should get 0. Okay? So like I said, the format we want for the quadratic formula is everything all over to one side, and we have our expression or our quadratic trinomial, because it should be a quadratic trinomial, set equal to 0. All right? So we're going to move the 3 over. And then we're going to do exactly the same thing that we did in the last problem. Okay. So A is 6, B is 7, and C is negative 3. Again, if you don't need to specify the A, B, and C, like physically on your paper, having them stare you in the face, you don't have to. All right. I'm just doing this for the sake of organization. And so everybody's really, really following along with what's going on here, because I know this is weird and confusing and probably still kind of complicated. So negative 7 plus or minus the square root of 7 squared minus 4 times 6 times negative 3, all over 2 times 6. Negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 6 is negative 24 times negative 3 is 72. So 49 plus 72, all over 2 times 6, which is 12. 49 plus 72 is 121. Another perfect square. Nice. So that's 11. The square root of 121 is 11. So this is negative 7 plus or minus 11 over 12. Don't forget about those radicals, guys. Okay? So negative 7 plus 11 over 12 is 4 over 12, which you can't divide evenly, but it is a fraction, so you can reduce it. They're both divisible by 4, so this reduces to 1/3. Negative 7 minus 11 over 12 is negative 18 over 12, and those are both divisible by 6. So this is 3, this is 2, so this is negative 3/2. I'm not going to be super picky with whether you leave it as an improper fraction or a mixed number, as long as it's a fraction and not a decimal. Okay. Last question. The discriminant is different, all right? The discriminant comes from the quadratic formula. It's a piece of it. B squared minus 4AC. That's it for the discriminant. But what it tells you is the number of solutions rather than the actual solutions themselves. So I saw this on a lot of you guys' homeworks when we were talking about discriminant versus quadratic formula. You really have to read carefully because a lot of people for discriminant questions were still actually finding the solutions and giving the solutions instead of just saying there are two solutions, there's one solution, there are no solutions. So please read carefully, okay? But it's still the same sort of idea. A is -3, B is 2, and C is -2. So now we're just plugging all of this into just that. So 2 squared minus 4 times -3 times -2. 2 squared is 4. -4 times -3 is 12 times -2 is -24. 4 minus 24 is -20. And what matters here is not the number itself, but the sign. If you have a positive number, there are two solutions. If you get 0, there's one solution. And if you get a negative number, there are no solutions. Please, also, if you look up resources on the internet, it talks about real solutions, all right? There are such things as non-real solutions, all right? So if you do get a negative number in the discriminant, it is possible to have some kind of answers, but we do not talk about that in Algebra 1. You see that in Algebra 2, and most of you are going to take Algebra 2 in 2 years, all right? That's going to be your junior year for most of you, all right? So I saw a very small handful of people using I in their homework, but since we are not talking about it, I don't want you to use it, all right? Even if you are looking at the internet for supplemental resources. All right, please be honest in your work. Please use integrity and all that fun stuff. I am really trusting you guys. And if I do, catch any cheaters, we're told to proceed with cheating as we normally would if we were actually physically in school, which means you would get a 0 on the assignment. I'd have to send it to the administration. I'd have to call your families. It's not going to be a good time for anybody. I don't think anybody wants that. All right. So please be honest, use integrity, all that fun stuff. Reach out for help if you need it. Go back to that post on how the check is going to work if you're a little bit confused, because you will have to submit handwritten work and pictures of it. So I am also asking you guys to look at some apps that can convert pictures into PDF files. If most of you, I think, are pretty okay with me being able to read your work, but please make sure the pictures that you send in are legible and clear. It's going to be really difficult for me to read your handwriting if it's blurry, and I am probably going to end up calling you out on it. I did post some videos on, I think this is the last, yeah, we're done after this. I did post some videos on a couple apps, so please, please, please look into that and try to master one of those if you haven't already done that. And we're over half an hour at this point, so I think I'm going to stop rambling, but please send me any questions or concerns if you have them, and good luck on all of this. Continue to stay safe, stay healthy, make good decisions, and I will talk to you guys very soon.